Welcome to The Explainer. Today, we're zeroing in on one of the absolute best tools we have as humans, the art of explanation. The universe can seem totally chaotic, right? But when we break things down, when we really look under the hood at the mechanics of how things work, we can decode pretty much anything. So in this explainer, we're going to master that art by decoding three vastly different phenomena. Let's pull back the curtain and see how they actually operate. Here is our roadmap for today. 1. The mystery of black holes. 2. The science of beeswax. And 3. Writing a movie screenplay.
Starting off with topic number 1, the mystery of black holes, decoding the cosmos.
So what actually happens when massive stars die? Well, to really understand a black hole, we have to start at the very end of a star's life. When a massive star, and I mean much, much larger than our own sun, finally runs out of fuel, it doesn't just quietly fade away. No way. It explodes in this absolutely spectacular blast called a supernova. But the really fascinating part is what happens next. The core that's left behind basically collapses in on itself under its own massive weight, and it forms what is essentially a cosmic vacuum cleaner.
Now, this brings us to a really mind-bending concept, the singularity. When that star's core collapses, all that matter is crushed, basically out of existence. It gets packed into a point in space that literally has zero size. But here's the wild part, its mass remains. All those atoms and particles might be gone, but that mass stays right there to create a gravitational field that profoundly warps everything around it.
And if that singularity is the infinitely dense core, it's surrounded by an invisible boundary. Dr. Joe Pesci from the National Science Foundation describes it beautifully. He says the event horizon is a shield around the singularity, the last orbit outside of which material can escape. So it's the absolute point of no return. Once gas, matter, or even light crosses that boundary, it's trapped in that gravity forever and just falls right into the singularity. But hey, not all black holes are created equal, right? You've got your stellar black holes, which form from those dead stars we just talked about. They hold up to 20 times the mass of our sun. But then you have supermassive black holes. These are absolute monsters. They contain the mass of millions of suns. Actually, scientists believe every large galaxy is anchored by one of these right at its center. Our own Milky Way has one called Sagittarius A, and it is roughly 4 million times heavier than our sun. How crazy is that? Okay, so if no light escapes a black hole, you're probably wondering how we even detect them in the first place. Well, we look for the accretion disk. When a black hole spins, it pulls gas and dust into this swirling pattern. And as all that material spirals closer and closer to the event horizon, the friction heats it up to extreme temperatures. It releases brilliant X-rays and high-energy light right before it gets sucked in. So by spotting that glowing disk, astronomers can actually map out these invisible giants.
All right, let's bring it all the way back down to Earth for topic 2, the science of beeswax, nature's engineers.
We're talking about the number 8 here. Let me explain. Producing the foundation of a hive, which is their nursery and their pantry, takes an immense toll on the bees. It costs a colony a staggering 8 kilograms of honey just to produce 1 single kilogram of beeswax. Because of that massive energy investment, bees really only produce wax when there's a huge abundance of nectar available out in nature.
It's a highly specific step-by-step biological process. First, young worker bees eat the honey. Then 8 specialized glands inside their abdomens secrete liquid wax. When that liquid hits the air, it hardens into these little transparent flicks. Next, the bees chew them up to soften them, and as the wax mixes with pollen, it gets that famous yellow color we all know. Finally, they meticulously shape it into those structurally perfect, space-saving hexagons.
But get this, the engineering doesn't stop at construction. They have strict hive climate control. For this delicate wax to form correctly and hold its shape under the heavy weight of honey and developing larvae, the hive's internal temperature has to be strictly maintained between 33 and 36 degrees Celsius. So what happens if the AC breaks and it gets too hot? Well, nature has an explanation for that too. It's called bearding. If the temperature spikes and that wax foundation threatens to melt, thousands of worker bees will literally evacuate the interior and gather right outside the hive entrance in a shape that looks exactly like a giant beard. By leaving, they create empty space inside, which drastically increases airflow and ventilates their homes so the wax doesn't collapse. It's absolutely brilliant. And finally, topic 3, writing a movie screenplay, structuring creativity. Now you might think making a movie is just pure untamed imagination.
But the reality is, the mechanics of storytelling actually require strict structure. Just like a beehive needs structural perfection to hold honey, industry-standard screenwriting relies on an incredibly rigid format to turn a blank page into a blockbuster film.
Before you even worry about the formatting, you've got to nail down the high concept. This is the main idea of your story expressed as a simple what-if question. Think about Mary Poppins. The whole mechanical engine of that narrative is built on one high concept. What if a magical nanny changed 3 children's lives forever?
Once you have that high concept, you begin typing. But you don't write it like a novel. You have to write everything in the literary present tense. A screenplay demands that the action is happening right now, in this exact moment. You don't write, "she walked down the stairs," you write, "she walks down the stairs." It forces everyone reading it to experience the story as an unfolding, present reality.
And to actually meet Academy Award standards, your blueprint has to follow exact format rules. You're using a 12-point Courier font. Your scene headings have to clearly state if the camera is interior, INT, or exterior, EXT. First time a character appears or a specific sound happens, all caps. Oh, and you even have to set your left margin to exactly 1.5 inches. Why? Because that extra half inch is literally just there to leave room for the 3-hole punch used to bind the physical script.
Even the actor's emotions are mechanically guided right on the page. When you need to control the subtle emotions or actions of an actor during their dialogue, you use a parenthetical. It's a short instruction placed in parentheses, like whispering or holding back tears, that tells the actor exactly how the dialogue is to be delivered.
Mastering the mechanics.
As we wrap up this explainer, I really hope you can see the thread connecting all these things. Whether it's the invisible gravitational shield of a collapsing star, the temperature-controlled architecture of a buzzing hive, or the strict 12-point margins of a Hollywood script, true understanding comes from breaking down the mechanics of how things work. That is the true power of explanation. It's about finding the rules behind the magic. Our universe is just packed with profoundly complex processes waiting to be unpacked. The tools of explanation belong to all of us. So the only question left is, what mystery of the universe will you decode and explain next? Thanks for hanging out with me.